good afternoon, everyone. Welcome to the last talk of the day. Even though he just said it, let's all make sure we're in the right place. This is, well, it is when, why, and how to use the CDK for Terraform. If you're not in the right place, everyone shut the doors. Don't let anybody out. I got some stuff to preach. My name is Cole Morrison. I'm a developer advocate here at HashiCorp. And for the better part of my career, I don't know why I said that. For all of my career, I've been working with the programming language in some form or fashion. And because the languages that we use grow near and dear to our hearts, it was very fun for me to see the CDK come about to where I could start using one of these languages on top of Terraform and just infrastructure in general. So I'm delighted by that, and I'm happy to be talking with you about it today. If you want to know more about me, I'm all over the internet, so it's pretty easy to find me. Okay, so what are we talking about today? Well, first we're going to talk about what the CDK for Terraform is, because if you don't know what it is, the rest of the talk will get a little bit weird. And then we're going to go right into the big question of when and why to use it. And that answer is inevitably going to lead to some smaller questions and deeper curiosities. And after that, after we dive into those, we're going to go into a full demo that I hope will sort of tie everything together. We're going to put together a CDK for Terraform project from scratch and actually connect it to an existing Terraform project so you can see how you can mix and match those. And then I hope we'll demonstrate sort of a perfect scenario that I think the CDK for Terraform enables. All right, so onward. Try not to peek the mic out here, okay? So, what is the CDK for Terraform? We're going to answer this in two parts, what it is and does, and then also how it works. And I'm also going to assume that y'all have some base understanding of Terraform. Y'all paid to come out to HashiConf Global, so I think it's pretty safe. We also just don't have enough time. So what is it? The Cloud Development Kit for Terraform, aka the CDK for Terraform, aka the CDKTF, and my goodness, for the purposes of this talk, I'm gonna just say CDK because syllables. So that's what it is. What does it do? Well, it lets you write Terraform code in any of our supported programming languages, that being TypeScript, Python, Java, C#, and Golang. Now let's dissect this just a little bit to add some more clarity. Okay. The CDK is not the SDK, okay? So the SDK is our software development kit for writing Terraform plugins if you want to make a provider or provisioner to extend functionality or manage an external API. The CDK is going to let you make infrastructure using our providers and provisioners. So that's the first thing. The second thing is I said that it lets you write Terraform code, okay? Now, admittedly, this is my own definition. Our official definition here is that it lets you define and provision infrastructure in any of our supported programming languages, which is true, but there's a little bit missing from that. And that's going to bridge us right into how it works. So a lot of folks, probably not y'all, you're a little bit more advanced here, equate Terraform with HCL, so our HashiCorp configuration language. But HCL is not Terraform. Terraform consumes HCL. Terraform also consumes JSON and Kubernetes CRDs. So I've got this picture up on screen here that sort of positions Terraform as this platform that consumes these different inputs, does its thing, and then goes and provisions its resources, given whatever provisioners and providers that you're using. We also see the CDK for Terraform up there. Yes, we do. But even though this is true, it's not telling the full story. You see, because when the CDK goes and does its thing, it actually munches it down into Terraform compliant JSON. Okay, now I'm going to say that a lot because it's going to wind up being a point throughout the rest of the talk here. So I just kind of want to allude to here that if you're already comfortable with the idea of going between JSON and HCL, then actually you should be comfortable with the CDK. But I've got some code up here. I'm pointing to this folder called CDKTF.out. So after you're done writing your immaculate TypeScript code, which is the code we've got here, and you run one of our commands, CDKTF synth or deploy, it's going to munch that code down into Terraform compliant JSON, put it in this folder, and if you really wanted to, you could change into this directory and use the normal Terraform CLI, and you could pretend that TypeScript doesn't exist. I know some of y'all would love that. That would make me sad. I kind of like it. But my point here is that it's all going to the same place. It's all becoming the same thing. And if you know how it works, okay, if you know how it works, you can actually kind of answer the questions to a lot of the rest of this presentation. So that's all. See ya. No, I'm kidding. We're going to answer them. Okay, so let's get right into the next big question then, which is when and why to use the CDK for Terraform. So since it's come out, the most common question I get, the most common question we get really, is actually not this one. It's actually, well, should I use the CDK for Terraform or should I use normal Terraform? Or other tools, but I'm a HashiCorp employee, so anyhow. This is actually not the correct first question. The right first question you want to ask is actually just, should I use Terraform? And hopefully the how it works is driving home why this is the first question. Okay, do you want access to our thousands of providers or tens of thousands of modules to speed up development, our incredible community you're surrounded by, and our ever-expanding knowledge? Do you want that? You want Terraform? Of course you do. Y'all are here. You want Terraform. After you've asked that question, then you ask, okay, do I want to use it in HCL or do I want to use it in one of our supported programming languages? If it's in HCL, all right, we got your answer. You're going to stick with Terraform. But if it's one of our programming languages, okay, here is perhaps the answer you were looking for. This is when you're going to go to the CDK for Terraform. Now, I know I kind of pulled like the tablecloth out from under you. It's kind of a trick here, but it's true. When you're asking when and why to use the CDK for Terraform, you're actually just asking when and why to use Terraform. It's all the same. Now, a couple months ago, that may have been a little bit different when we weren't in GA status for the CDK, but it is now. Therefore, even the win's the same. Use it now. Now, from a high-level business and technical decision-making process, we're done, right? The hard parts of the question are answered. All that's left are the deeper curiosities and the smaller questions, all of which I'm happy to tell you are preference. But preference, right? It's not just a rational opinion, at least most of the time. Preference can also come out of the desire for performance, efficiency, a better workflow, and legitimate reasons, because we can't understate how much using something you prefer and you enjoy can speed up your efficiency. So let's go ahead and start with the big elephant in the room wearing sunglasses and the sparkly 80s jean jacket. And that is, all right, Cole, you said it's all the same, but still, I want to know, do I use HCL or do I use a programming language? Well, first, let me give you the cut, dry, boring answer, which is, well, it's going to boil down to your team, your people, your skills, their experiences, their skill sets, and whatever other infrastructure you have in place to support that. Not like cloud infrastructure, like people infrastructure. And notice here that I'm talking about your people and not your applications, because what your applications are written in, hopefully we all know that doesn't matter. Terraform loves all and can work with all. But to give you a little bit more, let's dive into two specific scenarios, because this is actually where we start hearing this question come up. And we're going to answer this in context of greenfield and brownfield scenarios. Greenfield being you got nothing at all. Brownfield, you're already down the road, you've got HCL built up, maybe you're all in on it. So let's talk about group number one here. A team of experienced programmers that know their language's ecosystem like the back of their hand. They understand infrastructure and they know it needs to be built. For y'all, go with the programming language. Give the CDK for Terraform a try. You are largely the group that we wanted to go after here. And I just can't understate how much productivity you're going to find when you get to work with something you really enjoy and you really know in combo and on top of the Terraform ecosystem as well. But for those of you that are in ops, and maybe you have no programming experience at all, and you have no desire to get any, okay, stick with HCL. And I understand novelty can be a draw, and no, the CDK for Terraform is new. We've got something like 7% of the Fortune 500 on Terraform at different scales, different sizes. We know it works much of the time before the CDK even came about. And it's not a knock on the CDK, because under the hood, the CDK is just Terraform, right? So I want to give one more shout out here to those of you that are perhaps brand new. Maybe you haven't started your journey into the cloud at all. You haven't done any infrastructure, you're new to the HashiCorp ecosystem. For those of you, I'm going to leave it up to you, but my suggestion is to stick with HCL. And the reason is very simple. As of, what is today, October 5th, 2022, geez, I should know that. At 340, there's simply more resources out there to learn HCL-based Terraform. There's more community knowledge, documentation, tutorials, and so those are things that are all going to be there to accelerate your learning. That being said, we are, of course, working on that. The CDK just went GA a couple of months ago. We're always adding new learn guides and tutorials, and you also know who I am now, so you can ask me. So, Brownfield, those of you who have already gone in on HCL and you're comfortable with it and it's working for you, well, this is very simple. Continue what you're doing. Stick with it. It's called the HashiCorp configuration language. It's at the heart and soul of so many things we do. It's not going to go anywhere. And as such, you are safe to keep building and loving what you're doing. But I will say, explore the CDK for Terraform in future aspects of your infrastructure. And we'll talk a bit more about why, and you'll see it in the demo. Trust me, it will offload y'all who are strictly platform and ops. It'll offload some time for you. So, where was I here? Yeah, final thing is that this is not a forever type of decision, okay? You pick one, you can move to the other, and you don't like that one, you can move to one of the other ones. We'll talk about that a little bit more here shortly. Okay, so there is this one. Let's move on to another sort of smaller question, but whenever we bring up many programming languages, someone's gonna ask, okay, fine, we're going with the CDK, which programming language? So for this, the easy answer is, of course, that it doesn't matter, right? All can get the job done. All can get the job done well. It's all going to the same place. And hey, like I said, if you have regrets, you can just switch. Not only can you just switch, but there's not a rewrite story here either. You got to understand, if you write some of your infrastructure in TypeScript, you can just leave it in there, write your next unit of infrastructure in Python, okay, and then just wire them together, and it's good. Now the shorter answer here, and probably the obvious one, is just, okay, it depends on your team. If you're all a TypeScript shop, you're probably asking, like, okay, why are you even bringing this up? Of course, you're gonna use TypeScript. The only way that this answer gets a little bit longer is if your team is skilled and productive in any of these languages. If that is the case, well, lucky you. And aside from putting them all in a small room with a pointy stick, I'm gonna just give you a question that you can use to answer this as well. And that's just, okay, how did you pick the language for your application stack? Whatever process you use there, you can largely use to make this decision, with one caveat, just one. That at the end of the day, it's all Terraform compliant JSON. I know I keep saying that, but this time it's for a different reason. The reason this time is because what you're building with this code that you're writing is not some high-performance web server, right, or CLI utility that's going to be dealing with chaos. Sure, it's going to be in a CI/CD pipeline, and I guess Git commits can be their own form of chaos, but I digress. Let's roll back here. My whole point here is that it doesn't matter as much. And so because of this, because of what you're writing isn't going to become dealing with chaos as much, okay, the performance differences between the languages is not as big of a deal. Please don't throw anything at me. I know, I said it, but it's really true. For this case, because of how it works, it doesn't matter as much. And that's actually pretty cool because it means we can optimize for human readability, human performance, and the people side of things. We don't have to worry about the typical things we might in a normal application. Okay, so case in point here, pick the one that works best for your people and your organization. If I go any further, then someone will start getting inflamed. So instead, I'm gonna move on to an even more contentious topic, all right? And I promise my answer is somewhat peaceful, and that is declarative versus imperative paradigms in infrastructure as code. Now, I can sense some of you eye rolling a little bit, fist shaking. I've even talked to some of you about this already, okay? So my answer here is a little bit short, but if you have been in this space for some time and you've been walking along, enjoying your time, and someone hits you in the face with a programming language, this topic's gonna come up. So to make sure the table's set and we can all eat, we all understand what we're talking about here, I'm gonna go through and explain the differences between these two with a very simple analogy, a grocery store analogy. So I've got two grocery lists here. Grocery list one's get carrots 10, get strawberries 10, get sodas 10. The other one, it's a little bit weird, but it says for each item, for each aisle, check every single item. If item is of X, Y, and Z, grab 10. And then at the bottom, your odd friend has written carrots, strawberries, and sodas. Okay, so one of these, the first one, is very much concerned with the what. Okay, it's saying, go get carrots. I trust you as a human being and your ability to walk into that store, get carrots, and actually check them and not bring me one that's been tampered with by a kid. And I have some other joke in here about, grocery delivery, but I couldn't find the punchline. Anyhow, if you have done that, then you know that sometimes you're like, why doesn't this app let me put in more instructions? Okay, why can't I tell them more? And that is what's happening on the second list. The second list is concerned with the how. Down to the fine-grained details, you want to specify exactly what you're doing. The trade-offs here are that the first list is it's readable, right? It's very easy to audit. It's very easy to reason about. The second list, though, gives you much more control, okay? And that's the difference. First list, the what, it's declarative. Second list, down fine-grained control, it is the how, it is imperative. Now that all being said, I know I've put these two against each other, but this is a continuum, okay? It is not black or white. You can have both and both. If you're writing Python code, you can write all your own custom arithmetic, or you can pull in the math module and just use that, or you can do both, and we would have both in one code base. Speaking of code, I've got hopefully you can see, some TypeScript and some HCL up here. On the top, both of them, we're just making some subnets. The top one's using a map function. The bottom one's using our count meta, our meta argument count to both make subnets. Neither are using some nitty-gritty for loop or custom iterator. Both are declarative, okay? And declarative does not mean simplicity of code. If that were the case, and I can show you some really complicated versions of both, and yeah. But, okay, so this is the fun part. The funny part is actually none of this matters. In the case of the CDK for Terraform, this is all somewhat of a straw man. Why is that, Cole? Why is that the case? Well, for the CDK for Terraform at least, it's because it compiles down into Terraform compliant JSON, which is declarative, meaning you can put as many imperative control flows as you want in your code, but at the end of the day, it's becoming this, all right? We are not here to bottleneck you into opinions and tell you how to work. We are here to augment and improve your workflows and let you speak to Terraform however it is that you want. And as I've said earlier, do not understate the gains that can be had from preference. Okay, if you really want to be purist, then why aren't we just all in JSON? Okay, and by the way, that JSON goes into Terraform, that's written in Golang, that goes to machine code. It's also imperative. So anyhow, my point here is don't let this point be the turning point for your decision process, at least in the case of the CDK for Terraform. Okay, so there's the heated part. Let's go ahead and move on to one more thing that we've kind of seen and is going to bridge into our demo, and that is the ability to mix and match projects in the CDK for Terraform with projects in normal Terraform. I've said it much through the rest of the presentation, and that this isn't an or, this is an and. Okay, it's not a rewrite story either. If you write it in one, you can wire it up with the other, write it in that one. And by the way, if you're like, okay, that was a mistake, we want to migrate out, just by using the CDK for Terraform, you've created your migration story already because it's already JSON. So there's really no risk here. And that is actually what we're going to get into with respect to the demo today. What we're going to be doing is we've got an existing microservices architecture built out on Amazon Elastic Container Service. It's all being brought together with a Consul service mesh. It's being version controlled on GitHub, managed and run in Terraform Cloud and guarded by HashiCorp Sentinel. So it's this really sort of delicious brownfield scenario if you're in Hashi, right? And what we're going to do is we've had this dev team that's working on a new service that they want to wire up to this existing architecture, and we're going to let them do some self-service. They're going to create their little universe of infrastructure using the CDK for Terraform and TypeScript. They're not going to have to worry about as much either. They're not going to have to worry about their cluster or their subnets or any of their security groups. Those are all going to be there. And along the way, we're also going to learn everything you need to know to get up and running with the CDK so that you can be productive. All right, so I don't have anything to give to the demo gods, so may they bless me going forward here, because this is live. Ah, it's up. Perfect. So hopefully we can all see that relatively okay. Yeah. Okay, sweet. I see some thumbs up from about halfway, so we're good. So what I've got up here first is the repo for the main infrastructure that I talked about, the one that's already existing. And I'm showing you this just to make this point that we're not going to be going into authentication, authorization, like setting up accounts and credentials and stuff like that, because there's plenty of stuff out there on that. So we're going to skip through that and just get right to the work. The second thing is I wanted to show you what we built and will be building. So this is primarily what's been built. What we're going to be adding is this images service right here. And that's what we're going to be building out in the CDK for Terraform. The other things to note is our ops team has gone ahead and set up a GitHub repo for our devs and a Terraform Cloud workspace that we can see over here. We've got the main Terraform workspace and then the CDK one that we're going to be working in. And then also we can just go ahead and check out the console where all of our services are live, and then our mini application here with the live services. Great. So with that being said, let's go into some fun shell stuff, shall we? So when you're ready to get started with the CDK for Terraform, you're going to run one simple command, CDKTF init template, the language you want to work in. And then I've got this local flag here because I'm going to keep state local for development purposes. But this actually doesn't matter because when we get it up into GitHub and then ultimately into Terraform Cloud, that's going to be what manages our state. When you run this, it's going to ask you some very simple questions, just project name, description. But I'm not going to run this just because I've already done it and I wanted to be able to use Git to do some stuff to make the demo move along a little bit better. But if you do that, what you're going to get is exactly what you see here. So along the left side, we've got some files. And if you're familiar with the TypeScript or Node ecosystem, those won't look like anything crazy. My point here is don't really worry about them because the ones you do need to worry about, we will touch on. But the main one is going to be main.ts. That's what we're going to look at. And we've got a helpful comment here telling us to define resources here. So the first thing we are going to do is hook up to the AWS provider so that we've got a connection to start making our AWS resources. And the second thing is set up a connection to Terraform Cloud so that we can get those existing values from the infrastructure that exists, like our security groups and the like, so we don't have to reinvent the wheel or perhaps burn it. So to do that, I'm going to come over to my shell here and do CDKTF provider add AWS. And this is going to go and get the AWS provider and make it available to me in TypeScript. Okay, so I can start working it straight within my language. And if we hop over back to my editor, we'll see package.json has added this as a dependency. If you're not familiar with TypeScript, this is just how we keep track of dependencies and install them. And for the Terraform Cloud thing, we actually don't need to do anything because that comes built into the CDK for Terraform package. Okay, so instead of typing this out by hand and inevitably typing it, I'm going to do a little bit of Git stuff here and actually just fast forward where I've already typed some of this out. And we'll see some changes here in the code. At the top, you can kind of ignore it. It's just me not directly hard coding stuff. I'm still hard coding it. But this is just not the credentials, but the settings to tell Terraform Cloud or tell Terraform here which workspace we're using. On line 18 here, we are hooking up to the provider. So now we can start making AWS resources. 22 through 25, same thing, except with Terraform Cloud. So now we can get existing values. And on 27, we see ourselves doing this for the first time. Our infrastructure up there, our Terraform Cloud workspace and project, is outputting a value called project tag that it wants in projects. And I've got that here just to show you how to do it. So let's make our first resource. It's going to be a CloudWatch log group. All right, and we'll see IntelliSense kick in here. We'll see some of the documentation pop up along the side. Now, the reason I'm showing this is not because I'm necessarily a VS Code fanboy, but just to show you the fact that when you go with the CDK, you actually get all the cool things in your programming languages ecosystem, plus the Terraform ecosystem. Now, that's pretty neat. So I'm going to fill that in, and it's going to take 3 parameters here. Pretty much everything we do in here is going to. And the first one is going to be scope, and it's going to be this. OK, so we're not going to go down this black hole of what this is in TypeScript because we would never get out of here. But for our purposes, this is my stack. And scope is how we tell this resource that it belongs to this umbrella of infrastructure. So that's all this is. The next thing we're going to do is give it a human readable ID. And if you're used to normal Terraform, you can think about this like the second block label on your resources. And then finally, a map of configuration options, which is just like attributes in normal Terraform resources. So we're going to give it a name prefix here, use the project tag, add a little bit here at the end. And there we go, we've made our first resource. If you've gotten into Terraform before, you know once you get to this point, you've actually learned quite a bit and you're pretty good to go. You can get a lot done. But it'd be pretty wild to like make every resource in this file, as you all know, if you've done anything with Terraform. And not only that, we're going to need another log group here. We don't really necessarily want to repeat ourselves because we're not going to have to. So I'm going to come back over here, do a little bit of git stuff again, if I can type. There we go. We're going to see some stuff change in the main file. You can kind of ignore that. We're going to go into this new file called logs.ts. And I know there's a lot of stuff going on here. Don't worry. We're going to walk through it. It's going to be pretty simple. First, let's take a look at what we know that already existed. And here is this new CloudWatch log group, right? So that's familiar. And then the second thing down here is just something that ECS needs to connect our CloudWatch logs to a task definition. And I've just chosen to group these into the same class because they usually go hand in hand, so it's just a bit quicker. The rest of this stuff, well, if it looks too unfamiliar, it's either because of TypeScript unfamiliarity or maybe just object-oriented programming. But let's simplify it here. We're creating a class called logs that's extending this thing called a construct. And this is one of the main building blocks in the CDK. A construct, what it lets you do in a nutshell is pass through a scope that lets you tell resources within what umbrella of infrastructure they belong to, along with a set of parameters to customize those resources. That's really it. That's all we're doing in here. This stuff up here, this is just type safety through TypeScript, giving us a nice interface into this class. So that's all we're doing here. And if we come back over to our main file, we will see us using this new logs construct to make two different service logs. So one for our main service and one for our sidecars. And the sidecars are going to be what Consul requires to get our main application wired up to the Consul service mesh. And then we see us passing those params, one of which is this, so our scope, and then also another one of our outputs from our Terraform workspace. Okay, so two things here. Let's take a break and take a look at this. First up, what you just saw here is like, I don't know, 80% of the work you're going to be doing in the CDK for Terraform. All right, what you're going to do is you're going to make a resource in this file, say, okay, this is getting a little bit big and I want to duplicate it. Let me go to a new file, make a new construct so I can pass through a scope to tell the resources inside what they belong to, and then give it some parameters to customize it. And then I'm going to come back over here, recompose it. Great. You're going to do this for most of your infrastructure development. The second thing is that you're probably wondering, well, this kind of makes me think of Terraform modules, right? What's the difference? Well, the difference is that when you're working in the CDK for Terraform, this is the native way to do it if you want to modularize your code. And if you're in TypeScript, this probably felt a lot more comfortable than perhaps what you've seen doing something in HCL, mainly just because you don't know it as well and you've probably done this type of pattern for years. So that's how you're going to be working with it on that front. But Cole, you said 10,000 plus modules. Where are my modules? Well, guess what? You can use those in the CDK as well, because if it works in normal Terraform, it works in the CDK. And that's what we're going to do next. So let me hop over here and fast forward in time again. Actually, before I fast forward, let me show you the file where you're going to do this. Here's a file called CDKTF.json, and when you want to use an existing module, you're just going to go to this Terraform modules property in this array and list out your modules. So I'm going to go ahead and show you what that looks like. So here I've listed the Consul ECS mesh task module, its source, and its version. When you've selected one, you're going to hop over and run CDKTF get. And this is going to go up, and this is pretty neat. It's going to grab the HCL or JSON version of whatever module that this was and convert it down to be usable in the language that you've chosen. So we can actually see that if we come over here, drill down into .gen, into modules, into this mesh task, and here we see the TypeScript version of it, so I can just get to working with it. Nice. So let me close that up and go back to my main file where we've actually gone ahead and imported that. I'm going to scroll down here. Now this is going to look like a lot, but just like with the log group, let's just sort of fuzz our eyes here for a second. We're passing through the scope to this construct, an ID, and then just a map of options. All the stuff you see here, this is just what ECS needs for its task definitions. The rest of it is just what this module needs to go ahead and add Consul to it. So nothing big there. But here we go. This is an example of using a module. So now you've got access to that entire ecosystem, right, in the CDK for Terraform as well. So we've got our blueprint for a service because that's what a task definition is. The last thing we need to do is make an ECS service. And there's not much to talk about here because you've seen the workflow for it. So I'm going to fast forward one more time here and hop over. We're going to see a new file created called ECS services. And inside we'll see this familiar pattern. We've made a construct that's passing through a scope and parameters to the resources within. And then we're coming back over to our main file. And here at the bottom, we are instantiating that service. Now, I've pointed this out before, but some of the parameters we're passing here are really convenient for both the devs and the platform team, right? Which are, they don't have to worry about their cluster. They don't have to worry about what private subnets to put it in, and they don't even have to think about security groups. Hopefully, these have been documented. I mean, they were in my head, but you get it. It's a demo, it's an example. They'd be able to just use these and get going with just their small part of the universe. So one final quick step now that that's done, because we're actually done. This is all that needs to happen. We're going to run CDKTF synth, and this is going to crunch our code down into my favorite 3 words in this presentation, which is Terraform compliant JSON. And I'm going to go in the folder here, right into stacks. And here we see the JSON representation of everything we've been working on. So if your ops person even just wants to come in and give it a quick read through just to see if everything's good, this is what you could point them to. Okay, so we only have 2 things left to do here. One is to push it up to GitHub, and the second is to connect that GitHub repo to Terraform Cloud and run it. Now, I'm not going to do that. I mean, I'm going to do it, but I'm going to fast forward where we've already got some of this made just for sake of time. So just sort of watch my screen here. Okay, you didn't see anything, right? This is the same code. It's the same code. The only thing that's different is it's actually up on GitHub, and I've got a README and some other helpful stuff. So let me show you the GitHub repo here that you all can check out if you're curious on how to do it. If you feel like I sort of flashed through the setup and everything, I'm showing you this repo to give you a place where all the instructions to set up everything you need to work with are right here. So once you get this up on GitHub, the next thing you would do is come over to our workspace that's been made for us, go into the one that's made for us. I guess I just said that. And you'd go over to Actions, start a new run, start the whole plan and apply process. But I'm not going to do that because I've already queued it up for us for sake of time. So I'm going to drill down into this run, and we're going to see that it's gone ahead and it's failed. So before you start grinning that the demo's failed, this is intentional. So what's happened is our platform team has set up a Sentinel policy to watch this repo because they don't trust the devs, rightfully so. And they're saying, hey, every task definition you make should have a tag specifying the team and which team. And we failed to do that. So let's go ahead and fix that. I'm going to hop back over to my repo here, go down to my task definition, and I'm going to just add that in. Save it, and we are one of the dev teams. You can't see it, but in the policy, we only allow dev, sec, and ops. Yeah. Anyhow, this is good, so we're going to hop over to the shell for this one and run a CDKTF synth. And it's going to crunch it down. Uh-oh. Bring back the demo. Okay, there we go. See, that was a hiccup. So now we've got that all munched down. We're going to do a git add, a git commit, and then we're going to push straight to main. Okay, just, it's a demo, right? Okay, so this is going to go up. We're going to come to here, discard this run, and take a look at the other one, and then we're going to talk a little bit about some of the stuff we saw. So while this goes, you saw me running CDKTF synth. You're probably asking yourself, do I got to do this every time? And yes, you do, but you probably won't be doing it manually. We have a GitHub action you can use that can automate that for you. And also, my colleague Dan Barr is going to be giving a talk on GitOps. I should know the time. It's tomorrow. And he actually shows how to use that GitHub action, so check that out if you're curious. So this is going to go through, and the reason being is because Terraform Cloud wants to work with, obviously, Terraform compliant JSON or HCL, and it's all the same under the hood, and this sort of sticks to that philosophy. So the plan here is going to finish up, and the next thing, the next thing is Sentinel, right? So if you don't know what that is our policy is code tool. And so what happens here is in between every one of these steps, we actually generate little files. Well, I mean, they're not usually little, but we have like a plan file, and I'm going to go ahead and confirm this while we keep talking. A state file, which you know of, and Sentinel gets to access those, and using the Sentinel language can look through stuff like your task definition, look at the task definition itself and say, hey, there's no tags here, and then give a success or fail. And that would be a Sentinel policy. Now to use Sentinel, step one is learn Sentinel. So, that's kind of a hurdle, but it's not too bad. But the rest of it's simple. After you do that, you're going to just make a GitHub repo with a root sentinel.hcl file where you will specify your policies written in Sentinel. And then you'd come over to your Terraform Cloud account, into your settings, down to policy sets, connect that repo. We'll see that I've done that here for the one I just showed you. And then you can choose the workspaces you wanted to apply to, and we have just put that on the CDK one. So now we have that control. I know I only have one policy, but obviously, and also in this repo, you'll find all sorts of other different policies that you could use. Okay, so let's go check in our console here. We refresh here and see what is going on. Here we go. It's unhealthy just because it's coming up. Don't worry, demo gods have not abandoned me yet. It's a promise. So this is coming online. There is one more thing that we need to do though, and that's going to be, there's one small change we need to see. See, I had faith. There is one small change we need to make to the client that the ops team was already aware of, and because of that, they've gone ahead and queued this change up, and we're gonna go ahead and run it through. And someone's gonna ask me, where's Sentinel for this? The truth is I just didn't have time to write that policy, but we'll just say it's because the ops team never fails, right? Y'all are infallible. So I'm gonna go ahead and push this through. This is going to do its business, and while it does so, let's talk a little bit and summarize what we saw here. So we had an existing infrastructure already built out, and microservice architecture, and we wanted to extend this with one service, but this time we wanted to let their developers self-service. So they used the CDK for Terraform and TypeScript and largely followed the same flow that everyone is probably used to if they're working in Terraform. We have GitHub for version control. We're using Terraform Cloud to wire it up. And we even had it guarded by Sentinel, which is pretty neat. Even though it was in a different language, the platform team didn't have to go and learn it. They didn't have to change Sentinel or anything like that. It still just worked. Now, the reason I'm bringing this up is I promise you it's not because I'm trying to fill time while this finishes. It's because this pattern scales out. We just did it in TypeScript, but if you want to do it in Go, if you want to do it in Java, C#, or really if you just want to do it again in HCL, you could do so, and it would just work because it's all the same under the hood. It's all Terraform. Okay, so with that said, let's go check out, see what's happening here. All right, it looks like we've got another instance of our client that's come up, which is probably the one that's aware of images. It's probably draining the other one, so I'm going to be a typical user here and just come and just spam refresh till this just shows up. Yeah. And by the way, I'm using fake service here, which is made by one of our dev advocates, Nick Jackson, and it's excellent. If you wanted to repurpose this for yourself, you would just swap out the Docker image I have in it, change up the port mappings, and you would have to change up the port mappings on your security group rules, but that would be about it. I mean, I'm sure there'd be other stuff. Let's go to the root here and just look at the main payload till we see it pop up because, I still have faith here. Come on. We can do this, can't we? We can do this. This is the last session. This has got to work, right? I promise this is coming up. And unfortunately, I don't have any other filler to give you here while this comes to come up. So, yeah, perhaps I am draining it further. Okay. There it is. All right. There is the images service made in a CDK for Terraform. My goodness, and that is the end of the demo. So if we could see the slides one more time, we will wrap up and all go home. Well, actually, we'll all go to the social, right? Tonight at 6? Yeah? Okay, cool. Can we have the slides back? Please? Yeah. Well, anyhow, while we wait, I guess I can go ahead and talk. It's okay if we just end on the fake service thing here. Hopefully this gives you a window into what the CDK for Terraform brings to the table, right? No matter where you are in your journey, whether you're brownfield, greenfield, brand new or not, no matter what end of the spectrum, the case in point is that more optionality and more flexibility is a good thing in our infrastructure. Yeah, I mean, it really is. What I find interesting is that when it comes to application development, the whole polyglot programming paradigm is largely embraced, right? Especially with container orchestrators becoming such a linchpin in everything that it is that we build. No one complains about using this language or that language. We all just do it. We love it because at the end of the day, it makes us more productive. We can get more people involved. But when it comes to the infrastructure as code, there's still a bit of pushback, and with good reason for certain tooling. But for the CDK for Terraform, that's not an issue. And now you understand why. Because it's all just Terraform under the hood. So what I'm trying to tell y'all is that the CDK for Terraform, it's bringing this special, flexible, universal approach to infrastructure as code in any language to the Terraform ecosystem. And come on, that's pretty cool. So check it out, experiment with it, go use it, spread the word, because it's pretty sweet. Ah, yes, here we go. The slides are back. That was the slide I was going to show you, the perfect scenario. So up here, I've got some links to the demo repos and the learn guides and documentation. And you can find me at Morrison. And thank you very much for coming to my talk.